All right, it's now 3 minutes past the hour. I think everybody's going to join us now here. Again, a very warm welcome from our side here at Helmholz. My name is Bastian Ziegler. I'm the export sales manager at Helmholz. And today I'd like to introduce you to our technical director, Mr. Bokholt, who will in a second start with his presentation of our great new product, the PROFINET to MQTT Coupler, that will get you to put your data easily from PROFINET to the cloud, like the title says. Lean back, enjoy the show, and I will hand over to Mr. Bokholt.
Okay, good morning. Thank you, Mr. Ziegler, for the introduction. Yeah, okay, once again, my name is Carsen Bokholt, and I'm Managing Director at Helmholz and also responsible for the product development, product design, and future products. And today I'm proud to present you our new product, which helps you to get directly in the cloud from PROFINET. So let's start. Yeah, okay. What is the application? What is the need we have here? It's about data access from the cloud to get data to the cloud from a machine. So I have here a picture of a machine, a small machine with a PLC, some devices, and I now want to get data to the cloud. So this is a typical application, a typical need of many customers at the moment. And one typical approach, and also it's a challenge to get data, is to have an external access. So the typical approach is to get an edge device, like this device here on the right side, and to put it in the machine or on top of the machine at the end customer, and to connect this device to the machine and to collect the data, to access to the data in the machine and to send it to the cloud. So this is a typical edge device approach. So, but if you do this after you have installed the machine, or if the end customer is demanding this data collecting, and you put a device after you already installed the machine, after you already designed the machine, tested the machine, you also have the discussions which data you want to access, and more important is which data can be written. So also a big problem is data writing, and so this is also a discussion you have. And if you solve it like this, the edge gateways is also always an active component which has an access from outside. So you put it from outside and it is connected to the network in your machine, and it will get data from the machine or write data in the machine, and possibly you don't have the direct control about this device. So this is a challenge you have here. And we had a thinking about how to get this application in a better way, and we using the MQTT protocol for sending the data to the cloud. So this is the first step to decide the protocol. And a couple of words about the MQTT protocol. MQTT stands for Message Queue Telemetry Transport Protocol. It was invented by IBM many years ago, and it's an OASIS standard. So it's standardized. You can read the standard. It's open standard. It's you don't have to pay any royalties to anybody. You don't have to be a member of any club. You can just use it. So it's open. And the concept behind MQTT, it's a publisher-subscriber concept. So you have a publisher, which could be a sensor, like a temperature sensor in my example here, or it also can be a PLC. And this sensor, this publisher, is publishing an information, for example, the actual temperature. And in all MQTT setups, you have a broker in the middle. The broker is a collector and distributor of the data. So he collects data from the sensors, and he is also distributing this data to interested parties, and the interested parties are subscribers. So a subscriber could be a laptop, could be a mobile device, The laptop has some analyzing, some predictive maintenance software on board. The mobile device is just a device which can, for example, show the values. And these devices subscribe to the broker that they are interested in this data. So they say, okay, if there's a new information from the temperature sensor, I would like to have this information. So this is a subscribers. And the data in MQTT, the data identification is usually in text form, so you can easily read it. For example, this is an example here I have from the mobile, from the automated home stuff. So if you have your own flat, your own house, you can use MQTT to control all your lights and heating and stuff. And the identification of all this data is done by text form, in text form. For example, you have the living room, you have the light, and you can switch the light in the living room. The slash here means this is a separator of different logical units. So you can have the living room, the light in the living room, and you can switch it. You can also have the living room and the heater and the temperature, the set temperature. And this is called a topic. That is a name in MQTT, what one data point is. One data point is a topic, and the topic is described by this text form. And the topic also has data. So, and data is also open in MQTT. You can have just simple data, just the value, like here on top, 21 degrees Celsius, or just 21 if you don't want to have the type of the value. But values can also be structured. So if you have more complex values or more values from one sensor, you normally MQTT uses a JSON formatted. So these are two possibilities: to have a value just as the value. It's also sent like a string, or you have it structured in a JSON format. MQTT also uses encryption, so that's not possible to read the value on the line, and also authentication. So you can have different levels of authentication, so that not everybody can read values, not everybody can write to values. You have to be authenticated. So, and this is the protocol we use, MQTT. MQTT is widely used in let's say mainly all cloud solutions, all high-level predictive maintenance software, visualization software, but mainly in the cloud. MQTT is used as a standard protocol. And our approach to this, how to get data from the machine to the cloud, is the new MQTT Coupler. And what does it do? We have a machine with PROFINET, with a PLC, a running machine, or a machine you are just at the moment designing. And you put in this machine, this MQTT coupler. On the left side, you have a network interfaces to connect directly to PROFINET. And on the right side, you have a second network interface, a separate network interface to connect to MQTT participants, like a broker. For example, if you have a local broker, a typical local open source broker is Mosquito, but this is a main application. You can directly connect the MQTT coupler to the cloud. So you can directly go connect this over a router, over a gateway to the internet, and then directly set up a connection to different cloud applications. Those networks are totally separate. So you have one network on the PROFINET side and the second network on the internet side, and these are not connected. So this is totally important. You only exchange IO data. So you have PROFINET IO data, which is communicated over the PROFINET network. And this IO data will be copied to the MQTT side and sent out or received by MQTT protocol. The device is able to publish data, which is a standard case. You have data in the PLC, you want to publish it to the cloud, but also, and this is important here, you can subscribe to data. You can subscribe to data you have in a broker somewhere and connect to the cloud or to a local broker and get data from outside. And the configuration is done easily by a GSDML file, which is then included in the TIA portal, for example, and you design or you set up the data exchange while you are setting up the machine. So in the design phase of the machine, or later the machine is already running, but the machine developer, the company or the guys who developing the machine decide by themselves which data is allowed to be exchanged. So you decide inside the PLC, inside the project of the PLC, which data you want to exchange. The data is inside the IO area of the PLC, and you can then in your PLC program decide which data has to be sent on which event, or even if you receive data on the inputs, you can decide by yourself which data is allowed to be used in specific application use cases. Okay, to go a little bit deeper in the device concept. On the left side, we have this PROFINET interface, and the PROFINET device has outputs. So from the PLC comes data, and we have inputs. And the outputs are directly copied to the MQTT client side. And if an output changes, the MQTT client is directly sending this information. And the same on the other side. If you have inputs, and if you subscribe to some data on the MQTT side, the data will be available as inputs in the PLC. So also really important, it's not only a network interface isolation, it's also a galvanic isolation in this device. So there's no network communication between the two sides, and there's also no physical connection between the two sides. So both network interfaces are totally isolated from each other. And this is important if you have on one side the PROFINET, on the other side the network in the production line or in the end customer network. These are totally separated. So this also is a matter of security you have here. On each side you have two ports. PROFINET is usually used with two ports, for have one port in, one port out to the next device. So it's internally switched. And also on the right side for MQTT, they have two ports. Both ports have the same functionality. They are switched. So you have a small switch inside this device. We also have a redundant power supply. You can see it here down. Power supply 1 and power supply 2. So you also can have the power supply from both sides, from the machine side and from the end customer production network side. So if one side is failing, you get an information inside the other network. The device will always run. The device has a total compact design. I have here one device. You can see it's in my hand. It's very small. It's not high. It's not wide, and also very important. It's not deep. You don't. You have the DIN rail connection here, and you put it directly on the DIN rail. And you can also use the device in small cabinets, like cabinets which are not in the main cabinet. You have some outside cabinets or small places you can put them, and even if you connect the cable on top here, you don't need so much space. This is really important in our devices. We have a web interface on the device, so also firmware updates, and firmware updates are needed sometimes because of new features or even security stuff is possible over the web interface. And all our PROFINET couplers, we have different PROFINET couplers, are PROFINET Conformance Class B certified. So this is for sure. So you can use them in the PROFINET networks without any problems. Okay, Let's make an example, go deeper in this data exchange system, because data exchange, a PLC is a total different thing than a cloud data. So in the PLC has IOs, a PLC has a fast running a program and controls a machine. And on the other side, I have a cloud with data collecting, data aggregation, artificial intelligence, visualization, predictive maintenance, and all this stuff. So these are totally different worlds, and we have to bring them together. But it should be easily for the machine builder, for the people who make the concept of the machine, to have it totally easy to exchange the data. So yeah, we start with in the PLC. We want to send some information to the cloud. So we have an output word, temperature, for example, transfer to the temperature output word, and this will be published as a value, as an MQTT topic with the name temperature, with the value, the actual value, which comes from the PLC. The broker receives it, and the broker will then send it to subscribers. And the same way back, if you configure the PLC that you are interested in some information from some device, like a mobile device, like something, you can configure it. A mobile device, for example, is sending a set point as a new set point for your controlling, possibly the temperature set point, to the broker, and the PN MQTT coupler has subscribed to this value upon startup. And then if the new value is coming, the broker is sending this to the PN MQTT coupler, and it will be available as an input value in the PLC. So this is totally easy to understand. Sending data will publish data, and subscribed data will be available upon change. So this is totally easily in the concept. We can transmit bits, bytes, words, and double words at the moment. And they are transmitted in human readable form. So this is also a good thing of MQTT. You can always have a small test program to get the data, to see which data is to transferred. And for example, you see a decimal value, hexadecimal values, or floating point values. And the bit can also be sent as 0, 1, or yes, no, or on, off, as you like. So it's also human readable. Values will be automatically sent. So if some value is changing, the change of the value is an event to publish the new value. And if we receive a value from a subscribed information, this received value is permanently available as input. So it's a steady value you get inside. Upon startup, the value will be 0 because we get no information. But if we subscribe to a value and the broker already has this value, you get the latest value. Okay, so this is totally easily to exchange data. And also a big topic is always security. And security is organized with different measures. We have a user password possibility in MQTT, just the username and the password. And the MQTT broker knows all users and passwords and also the access rights. So the MQTT broker can be configured to see if a special user is logging in and wants to subscribe or wants to send publish data to the broker. The broker knows if this user is allowed to do this on this level. For the communication itself, the communication can be encrypted with TLS SSL TLS version 1.2. So there's the possibility to read the data online. And I talked about user and password. This is more an old technology. Today, you use authentication with certificates. So you also exchange certificates between the device and the broker, and this certificate enables the rights management, enables if you can send, publish values, if you can receive values. So this is a actual technology which is used between, for example, an Amazon cloud or complex cloud systems. But the most important thing is for testing or for evaluating or for the first step, all is optional. So you can just start to take this MQTT coupler. Don't use any certificates, any user password stuff. Just download one of the small MQTT tools, start a broker, which is totally easy, and then you can try your communication without any complex certificate stuff. Okay, yeah, some example how the data transmission is configured. So just we have a table here. This is an example. I want to exchange some values between my PLC and the outside world on MQTT. And as you know, if you configure stuff in a PLC, in a Siemens PLC with a TIA portal or even with a Simatic manager, the old Simatic manager, you put in the device like the MQTT coupler, and then you have all these slots. And these slots you can plug in modules. And this is how we organized it. You can plug in modules in this slots of the MQTT PROFINET configuration. And there are different modules available for different needs. For example, you can have an output byte, 1 byte, and hexadecimal. So I just want to send 1 byte, want to publish 1 byte, and the format should be hexadecimal. And then you see it will be published. You can give it a name, a topic name. So somehow on the MQTT side, you know what data it is, and then the value will be shown as hexadecimal. Or you have an unsigned integer in decimal, so you get a value like 65534. Or you have a signed double int, 4 bytes decimal, for example, bigger one. You also can have float, you can have bits, and this is for output, and you also have input. So you have these different directions. And for example, here we have the set point, which is an 1 byte decimal input, just a set point. Please heat the oven to 250 degrees. And the actual temperature is a publishing value, which is a 2 byte decimal. And for example, it's 25 degrees at the moment. These module types can be mixed, so it does not make any matter which module you put in first, and if you mix output and input, it does not have any relevance. You can have up to 100 different values you can exchange between the PROFINET side and the MQTT side. So 100 different variables, 100 different informations. And also size does not matter. We can have up to 1024 bytes you can exchange from both sides. So this is a concept. You just plug in modules to decide which values you want to exchange with the PLC. And here we have it in a TIA portal. And you see the TIA portal, you see the device itself, MQTT coupler. I just opened the device view, and you can put in these slots beginning with 1 until 100 different modules. The list of modules are here: byte, double int, unsigned, word, and so on. Different types, different sizes, and different presentation types. And you just put them here. And if you put in a new module, you can name it for the PLC side. This is a name for the PLC side here. And you can also give it a name, a topic name. So the PLC name and the topic name at the moment are the same, could be different. And in the topic name, you can also use these slashes for separation. You can just, here is temperature. This is easy. But if you have 5 sensors in the PLC, you can name it sensor 1/temperature temperature and sensor 2 / temperature, and so you have different sensor values. Okay, so it's totally easy to configure. And one more thing you have to configure, the PROFINET side is already configured by the PROFINET name, by the IP address in the PROFINET network. But we have a second interface, a second network interface. And this second network interface also needs some IP settings, because the device itself has to be present in the network from the factory, in the network from the end customer, in the network where the router is to access some cloud solution. So you are able to give the IP settings directly inside your PLC configuration. You can, for example, set the MQTT IP address to static, then you put in all the needed information here, or you can set it to DHCP, so the MQTT side gets the IP address, router, gateway stuff from the network, from the factory network, which is a typical case. But it's also possible to say, okay, I don't know the correct IP address. This should be done later on the web page of the device. So you do all this stuff to configure the data exchange in the PROFINET side, but you say, okay, I don't know if the machine is installed at the factory side, at the end customer. The guy from the administrator, the IT guy, should set up the IP settings from the gateway. So I will set it to setting via website. And then later I can access the website and then ask the IT guy, okay, give me the IP address of the gateway if the machine is installed in the end customer side. And also important is the web page. We have a web page, and we can have the web page on both interfaces, but you can decide if you want to have it on both interfaces or if you want to have the web page only inside the machine to be accessed, or if the web page can be accessed from the factory side, from the IT guy. And you can also make it seeable or accessible from both sides. And if everything is okay, it runs, you switch it off. So if everything is running, you can switch off the web page. It's also a security feature, and say, okay, it's running. I don't need to access the web page anymore. Switch it off from the PROFINET configuration here. Okay, so you see the web page of the PN MQTT coupler. I give you a short impression. How does it work? You need a login. Without login, it's not possible. And at the beginning, you have an overview. You see, okay, PROFINET network. It's connected. It has a PROFINET name. It has a PROFINET IP address. One port is connected. Everything fine. And also on the MQTT network interface, there is a connection, and everything is fine. Yeah, and okay, so the MQTT configuration is already done by the PLC side. So you can see it if you go IP address, it's on static. This is a setting here. And you see also we have a network time access here. And the next thing you have to do, okay, the device is configured on the PROFINET side. The device has an IP address on the factory side. But the important thing is, where is the broker? So, and this is the thing you have to configure on the web page to access the broker itself. And this is called MQTT client settings, because we are the client and we want to connect to the broker. And yeah, this is what you have to do. You have a username, a password, if you use it. You have the broker IP address. At the moment, it's a local broker I have here on my PC in a virtual machine, port, and some more stuff. And for also a MQTT payload data format, it's text at the moment. So that's all. You can just put in the broker address, you set up some stuff, and then it works. That's all, to connect to a local broker like a Mosquito broker or other brokers. Inside here, you can have some more. For example, you can enable all this encryption stuff, and yeah, so this will come later. And we also have a so-called module status. Module status gives you an information about the status of all your plugged in modules, of all your configured modules. For example, I have an output byte and the value at the moment is 0, and it will be published as output by and so on. And for example, you also have a temperature here, publish as temperature, actual value is 0. So there's no software running in the PLC at the moment. So you can also use this as a diagnostic system. And you will also get diagnostic messages if something is wrong, connection to the broker fails and everything. Okay, yeah, broker. So we have our client, we have our device, and we are able to send data, or we are able to subscribe data, but now we need a broker. And the broker, you can have many different solutions. One solution I already mentioned is a local broker, just in software. You can download, Mosquito is the name, you can download from Eclipse. You find it very easily. And you get this for a PC just started. You get it for Raspberry Pi. You get it for Linux machines. You get it for everything. And it's just downloadable, usable. You can use it, and it has all functions which MQTT offers inside. This is open source, just use it. If you want to have it a little bit more professional, a little bit more high-end, you should use HiveMQ. HiveMQ you get, it's from a German company, and it's already one of the biggest MQTT broker company. And this HiveMQ you can also have as a local on-premise version. You can start in a virtual machine. It's just running on my virtual machine. But more important, HiveMQ is a cloud broker solution. So you can use it in the cloud by yourself, or you can use it as a rental system. And HiveMQ is designed to handle millions of devices. So HiveMQ, one example, is used for Volkswagen, for all the cars, all the telemetry communication which is going on between the cars over LTE with Volkswagen service station, stuff like that. This is used inside in the cloud is HiveMQ as an really big cloud solution, and they can handle millions messages and devices at the same time. So this is a professional version, but you can start with an free to use 100 devices simple cloud version without paying money. So you can test your stuff. Okay, and I think more important stuff, if you want to connect your data, want to get your data in the clouds, is the direct connection to the different cloud solutions. And you see them here. Amazon, Microsoft Azure, IBM Watson, Siemens MindSphere, Google IoT, and even SAP IoT. All these cloud solutions can receive or send MQTT messages. So they have a broker on the edge in the cloud. So you connect, for example, and I would show you on the next pages, the device directly to Amazon IoT Core by sending MQTT messages to Amazon, and these MQTT messages, the values and the topics, are stored inside Amazon and can be used for many different things, like artificial intelligence analyzing, like predictive maintenance, like visualizations, like alarming, like name it. And Microsoft Azure is the same. IBM Watson has same abilities. So it's possible to connect to all these cloud solutions. And just to show you how easy the connection is, we have in our manual step-by-step explanation, but just to see how it works. In Amazon IoT, you call this PROFINET coupler, or more precise, the machine which is behind the coupler, because you get the values from the machine, not from the coupler, a thing, just a thing. And a thing you can understand as a digital twin of the device or a digital twin of the machine. And this digital twin discussion, the meaning behind this is that the Amazon IoT is handling this machine as a virtual instance, a virtual thing, and this virtual thing holds all the values which are coming from the machine or values which will be sent to the machine. Yeah, and for the configuration, I already showed you the web page, so it's totally easy. You have a broker address you want to access, and if you define the thing in the Amazon IoT, which is explained in the manual, how does it go, you get a link, a DNS link to the Amazon AWS IoT core. This is especially for this device. And it's a crypted connection, so you need an encryption and client authentication, and you get this from the definition in Amazon IoT. So you define a new thing, you call it PN-MQTT or my machine, and you do some steps very easily, and then you get this name to connect to the cloud and the client certificate and client key directly from the Amazon cloud. You put it in the MQTT Coupler, and that's all. And yeah, if you are inside this Amazon IoT, this is a screenshot from the Amazon IoT console or web page. You have these things management, and then you have a test option. You can just say, okay, publish set point. This sends an MQTT message with the value 1, 2, 3. Or you get here subscription temperature. I received on April the 12th, the temperature 1, 2, 3. And from this point on, you have the value, for example, temperature inside the Amazon IoT. From this point on, you can take this value and analyze it, put it in a database, do stuff with it. Okay, yeah, why do we do this? Why we are talking about data to the cloud? So we have just an use case. We have production data inside a machine or inside a company. This is running on PROFINET. We connected to PROFINET MQTT Coupler, connected directly to the cloud through the router, direct connection to the cloud. And then we are able to use it in the cloud with different technologies, which are already on the market. There are many companies on the market. They do predictive maintenance stuff in the cloud, but they need the connectivity. You need the connectivity to get the data in the cloud. For example, for predictive maintenance, visualization, overall equipment effectiveness, condition monitoring. So you name the buzzwords. And yeah, what is the purpose? What is the use case? We want to reduce downtime. We want to offer a fast service. So this is the next step of remote service. We want to have a transparent asset management. So we see, okay, it's not only the value of the machine itself, so how fast it is running. We also want to see if the asset, the machine itself, is running or not, if it's in service or not. So asset management. Yeah, you can compare the efficiency between different machines. So you roll out different machines to different end customers. They have the same purpose, they have the same setting, and you want to compare it. You want to see, okay, which machine, why is this machine running slower or has so many downtimes and so on. And this is also possible if you get the values in the cloud. Yeah, improve your machinery, improve it because you learn more information. So this is a viewpoint from the machine builder, and this is also a viewpoint from the user, from the end customer, which is using the machine. So we know that the machine builder itself wants to have information from the machine, and also the end customer requests data from the machine. And then you can say, okay, no problem, you can have it in MQTT. I just plug in this device and you get the data in a standard cloud format, and dear end customer uses data and it's widely used. Okay, yeah, that's all to this PN-MQTT device. I have just a product overview. The PN-MQTT is not the only device we offer. This is a total product range of PN couplers. We started with a PN coupler to connect two machines from PROFINET to PROFINET. The same features. You have two different networks and isolation between two machines. We have the same for Profibus to PROFINET. We have in Modbus TCP to PROFINET connector and Ethernet IP to PROFINET connector. So you see, it's a family, and these 4 devices, and we will have an PN EtherCAT soon, are for connection of machine to machine. So you have different machines from the same or different machine builders. You want to connect the data from one side to another, and this is a connection between data exchange between machines, also with isolation, network isolation, galvanic isolation, everything. And the PN MQTT coupler is the next step. You want to get data to the cloud or to external devices like brokers in the factory. And if you have still questions, just contact us. Bastian Ziegler is online, and you can reach him over this phone number. You can contact the support. You can even contact me, no problem. And yeah, would be nice if you follow us, newsletter, LinkedIn, Facebook. We will inform you about new products, next steps, because the PN MQTT coupler is at the moment in the beginning, and we are working on new features. We're working on new possibilities in the device, and could be interesting for you to say, okay, the product is already running, it's working for the cloud, but we have some nice ideas coming up with new firmwares.
Thank you very much for your explanations. The questions are already piling up, so we're gonna get through this. Michael asked, how many applications running now with MQTT coupler?
Yeah, we have a couple of customers already using it, and the most we started with Amazon IoT connection. So some customers already using it. We have one customer with Microsoft Azure already using it, and we have many customers doing some, let's say, more internal stuff. So they testing it with Mosquito or with HiveMQ locally to collect data inside their factory. So that is one part is the cloud connection, and but also this local data collection is applications we already have.
Another question by Michael, and then we get to the others. How fast is the communication with the MQTT cloud? Are there limitations?
The most, let's say, the point is the device itself with PROFINET is really fast. The data is really fast in the device, and we send an MQTT message in milliseconds. This is not the point, but the main thing is that many of these cloud solutions in the let's say cheap version we are using have a limitation. So if I do testing, I can send, for example, what have I, 100 or 200 messages in a second to Amazon with my subscription, and then it's all. More is not possible because there's a limitation for testing. I don't know how fast it will be if you have a good subscription, if you are want to use it in a really professional way. So the device itself can send messages thousands. We even have a limitation possibility. We have a factor you can switch on to limit the sending, because some brokers, some like Amazon, they don't like it if you send them 1,000 in a second, you know. And we have a limitation. You can switch on to say, okay, please just send every 5 milliseconds a new value, because it is too fast for the cloud at the moment. For our test subscriptions, let's say it this way. So the device is not the limitation.
Next question. This question is by Mehdi. It pertains to page 16 of the presentation.
Yep.
So his question is, could we use an Ethernet switch after the MQTT couplers for collecting data, and then after that use an LTE router for sending?
Yeah. So this pink line here for MQTT is just a symbol. The network you have in the end customer, it doesn't matter. You can have a switch. You should have a router, because the device itself is not a router. You need here at this position. If you go outside to the internet, there has to be a router, and because the device itself has no ability to connect to the internet. So you need a router somewhere in the network, and the typical applications you have, you put it inside the network, the end customer network or the factory network, which is normally connected to the internet. And it's a matter of router stuff. So you get the gateway information if you switch on DHCP, and then the device can connect. But you can also, for example, you can use the Rex 100 with LTE to connect to the cloud. It's no problem.
All right. Another question that came up is, do I have to use the TIA portal for the configuration of the coupler?
No, this is a standard GSDML file. So all PLC manufacturers with engineering tools which can read in the GSDML file. It's a standard GSDML file. There's no obscure things inside. You can use it with the old Step 7 software. You can use it with, let's say, other PLCs which have PROFINET. So it's totally possible.
Exactly. So that's also a major point of all our coupler products, of the entire family that Carsten just showed you, is that you can configure it with the standard software tool that you or your customer is already using.
Yes.
If you think of another question later on when you look at the presentation, for example, then please always feel free to call us or to write us an email. You had the contact data on the last page of the presentation. So if you're thinking of a question later on, here you see it exactly. Just ask me or call me or ask our support if it's more in depth, and we will be glad to answer it. All right, cool. I think this will be for today. Thank you very much for your attention. Thanks again to Carsten for the great presentation, and
Welcome.
hope to hear from all of you soon. And until then, stay safe, stay healthy, and see you soon in one of our next webinars. Thank you very much.
Thank you very much. Have a nice time. Bye.